So my name's Andrew Turner, and I mentioned that because someone actually tweeted saying she didn't catch my name at the beginning, so let's make sure and say it again at the beginning, and there it is on Twitter. Dave's name's on this, but Dave's been busy building product, so I will talk through this. I'll give you a little context about why we're building this. Again, just to use this in terms of what our quote day job is and how this is something that we're experimenting with. You can too, but kind of the why of it. So first off, kind of what we're thinking about, what we do in the DC Center is think a lot around how do we take our tools and make them more accessible, right? And the way that ArcGIS has worked for decades is it offers a system of record for cities, right? We typically think of cities as like a static entity with infrastructure, buildings, and parcels. But I think it's much more interesting when you look down at street level, and you look at the actual motions and movements through it. The city is not the buildings, the city are the people and the actions and the verbs that happen in that city, right? And in the end, it's about the people who live on that street. And no one cares around that city block as the people who live there. It's the biggest purchase decision you'll probably make in your life. It's where you fall in love and get married and have kids and walk your dog around and make friends and go to work every day, right? So how can we make this technology help you understand more about your street and engage on it and help the city and the government actually become better and engage with that community and more effective? So, and think about the different users that are in a community, you know, they're varied, right? Many of us often think about like that app I'm going to build for that mobile device for that user, right? And we often have our own experiences in our mind, and it's difficult for us to have the empathy for the person in terms of what experiences are comfortable for them. And so really what's driving this is not just bots for bots' sake, but how do we make all this complex data and information as accessible as possible? Whether it's because of visual impairment, physical impairment, or just the person's really good at things that aren't GIS, and they really care about their block and they want to be engaged, right? In DC, for example, there's 700,000 residents. Yet every day, 1.4 million people are in the city from commuters and tourists and visitors, right? And I'm sure this happens in a lot of cities, right? So how do we make it as easy as possible for them to engage with the city because they have no idea the city has a website or a mobile app or whatever else, right? So how do we get it into the experiences there? Another way to think about this is as Esri, you know, we support about 5 million users around the world. That's great. What about the other 6.95 billion people that live somewhere and want access to this data and this information, right? So this is the last stat. Pew Research did a study in which they asked people about how do you engage with your government, and do you go to your government website looking for data? And they found out 70% of citizens do. They actually do go to the website and look about where do I get my driver's license, where do I get a hunting license, what's my tax thing, what's the school rating near me. Yet less than 10% were actually able to find what they're looking for, right? So they're desperate for information, they're having a bad experience doing that, right? And that's not only what we're doing as the team building open data and now building Hub, and there's a lot of sessions here about that. So, and I'm highlighting this again, you heard a little bit this morning, it's around us thinking around how do we make the work you're doing more accessible? How do we make the work you're doing increase that impact, and how do we help scale that out, right? And bots and chat interfaces is just one way to do that we think is a compelling potential, but it's going to take, as you could see in this morning in my demo, a lot more work. So I'll just share kind of where we are down that path. So I want to talk about this in terms of, as I'm going to dive into these things, I'm going to start pulling up lots of code and tabs. So if you want to see more curly braces and semicolons, you will in my half hour. So, but I think this is useful to have in your mind. We can come back to it and talk about architecture, right? So at the back end, everything I demoed this morning, everything I will demo is leveraging off-the-shelf existing services. There's already an ArcGIS server in the city government for crime and bus locations. There's already a geo-enrichment API in ArcGIS. There's already a routing API in ArcGIS. These are very, very, very simple interfaces, although finding the docs is half the battle. When you find the docs, it's actually really easy, and I'll show you how easy. So the blue boxes down here are the tools that exist today, right, that you know and you love or are going to learn more about this week. What I wanted to do above that is how do I talk to those interfaces and how do I scale that out, right? So Lambda, if you haven't used Lambda, Lambda is an Amazon web service based on the idea of functional programming and Lambda functions from a lowercase l perspective, where I can write a line of a function and I can say, Amazon, automatically scale this to whatever servers and whatever you want to whenever someone calls it, right? And so there's different interfaces in terms of calling that function, right? So it's a function as a service, right? Not function inside a compiled application, but a function as a web service out there in the world. And I can call to it via REST and other formats. So on top of that, there's an API gateway in Amazon that gives you a REST interface, and as well as you can specify paths and endpoints to that REST interface, and that REST interface has to be backed by something. Amazon makes it very easy to be backed by Lambda functions. So the idea is if I call my endpoint, and imagine a feature service, right? You say /query. And right now that goes into a big Java application and a Tomcat server and so on to fulfill that response. The way Amazon would do it with API Gateway is say, oh, /query will call a function. And that function will go and fetch things out of a database or whatever just for that one function. Now that /query would be one modular function. If I get metadata or I do routing or something else, that would be different functions out there. So it also makes it much easier to manage a lot of complex architectures as well. And then on top of that, I wanted to tie into different chat systems. And to do that, to make it really simple for me, because this was kind of a spare time project, was to use an open source library called Claudia.js. So Claudia.js wraps up Lambda, and it wraps up API gateways, deployment, and then they have on top of it a Claudia API and a Claudia bot. So to be honest here, I did very little. I had to know about the blue boxes and read lots of docs in terms of ArcGIS and how to do that. Claudia made it very, very easy, and I'll show you just how easy that was. So keep this in mind in terms of as I start diving through things. So the building blocks I'll start referring to, just to give you upfront the different nouns and verbs you'll need to know. So first off is that there's different platforms, like interface platforms. So I showed off this morning Facebook Messenger and Slack and Amazon Alexa, but there's already built-in support in Claudia for Skype, Telegram, Viber, Line, GroupMe, Kik, and Twilio. Half of these I've never heard of, and I presume you're probably the same as me, but apparently they might be big. But what's interesting is what they do is they, as much as possible through Claudia and then writing these bots, is I don't have to deal with their APIs. I don't have to deal with those systems. It's all abstracted away for me. And what's really interesting about the last one, I like Twilio, because Twilio actually offers SMS text messaging support. So if you want to go to the accessible as possible, it's the idea that someone has a 2000 era Nokia phone where they can T9 text into things to get responses back. So everything I'm doing in Messenger could just as well apply to a text phone deployed anywhere in the world. And that's where it gets really interesting. But I didn't do that right now. So below platforms is the way that this is based on Alexa's terminology, although I've applied it as well in terms of how I was architecting Sonar. It has skills. So skills, Amazon will talk about it, has 10,000 skills in the marketplace. A skill is things like Spotify. There's a Spotify skill. When you turn on the Spotify skill, it has a number of intents, many, many, many intents. Search for song, play song, pause song, stop, louder, softer. Those are all intents inside that one skill. So when I did Sonar, so Sonar's the skill I can enable. I had a intent in there called get data is the method, tell me about, and then there's tokens, data set and location. Those are actually in Alexa terminology called slots. And I can have many of these intents. Each intent can define its slots. And then what's really nice is in the end, my code just gets a JSON structure. I don't have to deal with natural language processing. I don't have to deal with all these other things. It just gives me, it's like, the person is calling the get data function, and the input for data set was this word, and the input for location was this word. Go nuts. Give me back a text response, and I'll read that back out to them. Does that make sense? All good so far? So I think with that, I'm going to actually hop now into code and things. So I'm going to, also this is where it's fun, it's development of this stuff is not nearly as easy as it should be, is you need to have accounts in at least 3 different development platforms for this to work. 4 if you include GitHub, which is obviously optional. And just to clarify, if you didn't catch it this morning, this is the Sonar Repository. So this project is very much a work in progress. So I'm not proud of the code. It works nominally, but do know it was a project we were working on to demo the concepts and ideas. So when you look at it, you're saying, why the hell did he program it this way? It's not because I think that was a good idea. It's because it got the job done. And emerging in terms of where it's going to go. And I'll show you why it got a little weird in here and when you build your own bots. But the nice thing about this repository is it links out and kind of describes the things I mentioned in terms of the platforms it currently supports, the interface, and so on. So I'm going to use this to kind of highlight kind of what the terminology was I used in Sonar specifically in terms of what I wrote, right? So I gave you the building blocks. Now I'm starting to put together those building blocks into an experience and interface, and I'll talk about how that gets implemented. So these were in case I forgot also I could copy and paste these, right? So /Sonar, so this is what it is in Slack, right? So again, to show you what that looks like. Oh. Let's see if I can zoom it. There. So the slash command, if you've never used it in Slack, is saying I'm calling a command in Slack, right? And it shows me an example, and I can ask questions like, tell me about crime at So when I click enter, so I actually went into, well actually no, this is correct. So I mentioned 4 developer programs. You also need to sign up for a developer program for every single one of the interfaces you'll be working with. So I also signed up, besides having a GitHub, an Alexa, an Amazon, and an ArcGIS account, I now would have a Slack developer account and a Facebook developer account and whatever else, and I guess Alexa. So I'm up to 6 developer accounts just for this one project. So you will maintain lots of credentials. LastPass, 1Password will be your friend. So when I do this, I've registered now in Slack saying, when the /sonar command is called, I had a URL from the API gateway that I registered in it. So let's go to developers Slack. So I'm going to start walking down through this stack for you here. Your apps. So I have one app. So in Slack, I created an app, called it Sonar. Right, and here's why I can specify certain functionality. These are my different tokens that I'll need. And I'm not going to go through the details, but when you configure Claudia, you'll need to pour in all of your different tokens for these different protocols. Right, but the useful information here is the logo, obviously. But it is then, where is it in here? Slash commands. So I've said my Slack app has a command called /sonar. And when I call that, really, and this is where it's actually fairly simple, is it just says, okay, when I see /sonar, I'm going to do a post to a URL. Right? So in the end, very simple, right? So Slack is dealing with all the different credentials in terms of showing up in rooms and things like that. It essentially says /sonar really means this URL, and then it's going to send this entire string to that URL, right? And the really cool thing is, so while I say /sonar, tell me about crime at this location in Slack, if I do the same thing now in Messenger, right? And I don't have to do /sonar because in Facebook, the way it works is you create a page and you can message a page. But when I message a page, it's the equivalent of /sonar. I think I can also do like @sonar within Facebook and it works, kind of like Twitter. I can pass that exact same string in, right? So the nice thing is the string that's really an important part, right? And there's different protocols, whether I'm in Slack or Facebook or with the Alexa, right? That's why I always had to preface things in saying ask Sonar. Alexa goes, oh, he's talking to the Sonar app. I know the URL for the Sonar app, and it says, takes the string and throws it across that URL. So again, I'm taking all of these different, the 12 platforms Claudia supports. It's really saying in those 12 platforms, it's going to be a URL. It's going to throw in a string to that URL, and good luck from there. So I can go and do this. Tell me about crime at this location. It says that was the most recent crime. So I'm just doing a simple query with a buffer around that address. And then same thing here in Slack. I get the same response back, right? And it's a consistent interface. And this is, I think, one of the interesting things with these bots is developing essentially a nomenclature, a conversation, right? When you're talking to your family member versus another parent versus your boss versus a colleague versus someone you're managing, you might use a different tone and conversation with them. So you have to be really thoughtful in the user experience here about how you're developing that, right? But then make it consistent. And that's something that we're interested in kind of thinking and working on is what is that consistent voice experience that in terms of how do people talk to bots and things like that. So I spent a bit of time thinking around, tell me about this, ask me about this, where is the, when did the, right? These are things you have to think about because it needs to be very natural when people talk to it, right? And if doing it wrong, it's going to feel like a bad user experience, a bad strain as they think about it. So all those are consistent, which is great. So I get that string. Now, within that, kind of peeling down the layers, so that's the top boxes. So Slack and Facebook and Alexa took in a string and called the API gateway with the URL. Now, the cool thing with API gateway is I'll show you this. So API Gateway then has endpoints, paths, for each of the different platforms I'm supporting: Alexa, Facebook, Slack, things like that. I'm showing you this. When I was building the bot, I didn't have to go in here at all. I didn't have to touch any of this. This is all actually handled through Claudia for me. But it's nice because you can go in here and modify it if you wanted to, right? But the interesting thing is that this is where, when those URLs are called, it calls to here. This handles all the routing for me. But I didn't have to know that because, again, Claudia took care of that for me. Right? So it calls in this API endpoint, but just to show you what this looks like within here, when it calls, for example, slash, let's see, Facebook, and it does a post request, this is where you start seeing it itself diagrams this out. So on the left-hand side, the client, right, the Facebook Messenger, when it got an input method, it then sent that to what's called the Lambda proxy, right? So again, Lambda is actually the JavaScript I wrote. So in all this I'm talking to you about is setting up the whole path from my voice and my words getting finally to my function, but you need to know what these pieces are because you're going to be encountering them from at least a token perspective as well as a user experience perspective, and obviously a debugging perspective. So Lambda is where it starts getting actually then very interesting in terms of actually writing code in JavaScript. Go into Lambda just to show you this, but then we'll get into the code. So Lambda's managed again through Amazon Web Services, and I can manage all my functions here, and I can test these things out. So the nice thing is I can set up various test methods and try things out here at this layer. So along the stack, there's ways to debug and test just that stack, because when you build this, of course, it's going to break. You're not sure whether it's my Slack keys that I've messed up, or whether it's my API gateway configuration I've messed up, or it's the Lambda I've messed up, or it's my JavaScript code I've messed up. You can dive into any one of those, even though you generally don't have to manage those. I will admit, and probably the way it sounds, is it's not very easy. There's not really great tooling for working up and down the stack. So this is why it's still kind of early days for these bots. And then why this is a demo theater, not a workshop. So let me dive into the code, right? So now what's happening is it's going to call the Lambda functions, and it says that my code's too big to edit in the browser. So small functions, single simple line functions, can edit entirely in the browser. So let me dive into the code. So this is the root. Very easy, right? So I load the Sonar.js module. Now, this is where I'm not necessarily proud of this, but it worked. So what happens is there's an entry point. So this is actually what it's called. Through everything I've just covered for the last 5 or 10 minutes was getting from the voice or Facebook to call a URL to call a JavaScript function. This is that function, right? Now, it's a bit large, and it would be nicer to maybe get smaller, but this bot builder is essentially called, and inside these request objects has all the things about, this came from Facebook, and it came from this Facebook user, and here was the original string, and here was the time of day, and all the things you might need inside of it, right? But what I really care most about is the intent, right? Going back to, in particular here in this terminology, this intent specifically was get data. So to show you inside Sonar, here are all the intents that I have for Sonar. So I can say there's an intent called help, and here are the different strings that one might say when they want to do help. Hello, ping, get population, get crime, get data, summarize data, get map, and add note. So I have about a half dozen intents here, right? Based on these are the different ways you can have the intent. And what's really cool with Alexa in particular is you'll see that I have get data, and I have 4 different entries for that. That's the thing you're actually starting to teach Alexa in particular, and this only applies to Alexa, unfortunately. I'm saying, Alexa, the human could use any of these kinds of variations of this phrasing when they really want to ask about like crime or trash nearby them. You give all of those to Alexa, and Alexa actually builds an algorithm. I'm pretty sure it's a neural network algorithm that essentially trains itself on inputs in terms of like when I then talk to Alexa, it says, well, Andrew said, what is the crime of this location? Maybe you said, what's the, or what is crime of location? And Alexa's getting pretty good at doing that because, as I mentioned, there's 11 million Alexas in households right now that's constantly listening. And what they're not just doing from a listening perspective, they'll say, okay, well, the person tried to say the same thing 3 times. I probably wasn't right the first 2 times. And they're actually asking, and here, there's actually, when you log in as an Alexa user, I can actually see all the different phrases that I've done in the past, and I can tell Alexa whether they were right or wrong, right? So here you can see this is what finally worked on stage. Alexa asked Sonar, well, this is the one that failed, and it answered me with a population one. But the nice thing is I can go down through here, and this helps with the debugging, is saying, I spoken to Alexa and I got the wrong function. Was that my code or was that Alexa's parsing, right? Unfortunately, it's a bit of a black art in terms of how do you start saying what's a good set of variations on the intent phrasing to get a good comprehensive terminology for how someone's going to talk to your bot. But at least gives you affords you the ability to start doing this, and that's something to explore. So going back to the code then within this intent, and what's annoying is Alexa is very, very good at taking natural language phrases and pulling that into, here's the intent called, oh, you want to get data or you want to get crime, and here are the slots. Facebook and Slack don't do that. They just like, here's the string, good luck. So what this does right now is it builds a collection of regular expressions to try and do the same thing. And this is another part that's kind of a bit of a rough area in the current demo of Sonar that I think there's two paths to take here. There's one in terms of leveraging all the intents and building up kind of a better regular expression builder, a factory of regular expressions as it were here, or Amazon's now released, is starting to release Lex. So Lex is the learning engine behind Alexa. So it might be possible to leverage Lex as a learning algorithm for even doing these regular expressions for free text entries in things like Facebook and Slack. We'll see, but this is where I've essentially enumerated out, if I got text, turn things like what are the data set at location, here it'll turn that into a regular expression, build my slots, and at that point within my code, we'll actually turn it, and now it looks, my code says, I don't care whether it came from Alexa or Facebook or Slack, it's now the same thing. I have the intent that was requested, and I have the different slots for parameters, right? And then that's where I start calling, then I just have a big switch statement here, yay, to call the methods behind that, right? So get data says, okay, great, call the get data method, pass in the dataset slot, the location slot, and the environment variable. So tokens are going to be your friend if you've ever done any development. Right now you have to pass them around. So this environment variable passes around the ArcGIS token, which actually is stored in Amazon. But I won't go into that. So now let's look into the get data. Actually, the interesting one is the get directions. So in get data. So inside get data, what it does is it's a set of promises for callbacks. So it says, first thing you do when you get data is find out where the person, when they gave me a location name, 201 4th Street, Stanton Park, Empire State Building, it uses ArcGIS locator service to turn that into coordinates, a geometry. Then it says, okay, great, now I need to go and find the crime data set. I'm going to use GeoServices to call into that data set to now get at that XY with a buffer, get me back the features. Then I'm actually have a template that actually turns into a natural language kind of response. There are this many crimes at this location, or the trash day is this day. And then it returns the response, unless it's bus stops. Right? Again, this is why the rough patch of the code. So when it says bus stops, it's, bus stops aren't useful just for a bus stop, but I actually want to get the person to the bus stop. So add directions to that, right? And at least the thing I was proud of in the weekend was building this up into slightly modular functions. So if I look in the directions, and this is where I hinted at the beginning, if you want to look at how to call the directions API, you have to dig. But when you dig in, you realize that it's these few lines of code. This is all you need to do to call against the directions API. You essentially have a URL. You build an array of like start and stop locations or locations along the way. You throw out the API. It comes back with here's the lines and the names and the walking directions for all of it for you. So it's super simple. But that wasn't apparent right away. What is interesting then is that by figuring out that API, and one thing we'll be doing is to turn these into standalone little JavaScript functions if you want to use on your own bots. So we're going to start pulling this apart into functions because we need them and you need them. It'd be very easy for you to pull directions into any of your other methods, right? And actually start wrapping up more of the enrichment API and the directions API into small little JavaScript functions. Because the same thing is here in get enrichment. To do enrichment in terms of when I asked Alexa saying, how many people live nearby here, that called the geo-enrichment API, which said, okay, within 200 meters, give me numbers of households. I could do median income. I could do number of kids. I can look up number of kids who have bought a race car in the last 6 months. There's an amazing amount of variables there you can use and put into your apps, but also into these bots saying, Christmas is coming, people in your neighborhood tend to like kites or something, right? You could actually ask the enrichment API that kind of question. So, and this kind of encapsulate how to wrap up and call that function. So backing all out of that then, coming back up to Sonar is right, once it gets back that data, it then returns that as a promise. Within Claudia, it resolves that and sends the text back up through the API gateway, back up to the Slack or Facebook or Alexa, and Alexa then takes care of it for me, and I don't have to worry about that. What's really cool is as you're diving through this is how easy, and perhaps scarily so, it is to deploy these. So if I make a modification to my code, for example, on get data, I want to change, for example, the trash day. Trash day is, just coming on, or what day it is, it's coming up on this day. So I have it set up so npm run update. So this actually calls while that's running in the background. All I have to do to update is I have to call this one Claudia method, right? Claudia then handles calling to Amazon, pushing in my new code, resetting the servers for me. It's doing all of that for me by just running that one command. So it's a one command deploy up to your bot. So I actually deployed an update about 15 minutes before I went on stage, which is always a great idea. No, it's not. So once this is done, and then I'm done, I can recall my bot with the exact same question, and my response will be slightly different. There, so it's updated it. It gave me back kind of where all the different signature I might need here, as well as here are those API endpoints I mentioned. These are the things I would copy and paste these URLs into my different developer accounts for Slack, Facebook, Twilio to know the API endpoint to call. All right, so I come back to my bot. Sonar tell me about trash at. So, it's that simple to kind of deploy new versions of your code. What's great about it, I didn't do here, but within actually, with Claudia and with Amazon services, you can set up development, testing, and production environments. So you can say, well, I'm going to deploy rapidly to development, and then when I'm thinking I'm good, I'm going to push into testing and leave it be, and then production has its own gating function for getting there. Like you always do for demos, you push directly to production. I definitely not recommend that. Again, 15 minutes before a demo in front of 2,000 of your closest friends and colleagues. So I had a 30-minute demo. That was my demo so far. I do have 3 minutes if someone has a really interesting question that you want to ask me in front of everyone else. If you don't, then I'll be available afterwards. So you win. What's your question? So the question was, instead of just Claudia, well, Claudia specifically then using Amazon, have I looked at using the Azure pod framework? No. Bot framework? No, I have not. I have not. I'm sorry? Okay, so Dave was supposed to give the other half of this talk. Okay. What's your request, Dave? Finder what? That's it? Cool. You need some back. So it is a good question, right? This is just one because it was pragmatic and worked, right? Microsoft has theirs, and I think this is kind of like going back to that Gartner curve, if that didn't make sense, right? Like emerging in bots is right now just riding up that slope to the peak of high expectations, right? Over the next year, we're like, oh my God, we can like get rid of workers, the end of work, bots are gonna take care of everything, right? The reality is they're not, but what's amazing is that you have Amazon and Microsoft and many other systems gonna be competing to have amazing bot frameworks, right? And they're going to compete and have amazing voice interfaces on top of it. So, we're probably 5-10 years away before it's like, literally people are like, I don't need a UI anymore, and I'm just in my car, and I'm just talking to it because I'm not driving anymore, and things like that. But now is a good time to start doing that because it can be effective, right? You can build bots today, just don't think they're going to save the world. They're just going to provide a different interface into your work or your applications to people, right? There's a book out there by O'Reilly It's a free download around designing voice interfaces. It's a really good kind of quick read in terms of talks through how to think about things like, again, like micro content, tone, user experience, legal issues, right? If you haven't seen, there was a big news story around there was an unfortunate homicide in someone's house, and there was an Amazon there, and they're trying to subpoena Amazon for the recordings from the Alexa there, which I think ended up, Amazon's like, we keep a buffer, we don't keep it in storage, but it's going to start answering, it's going to start, these questions will get asked. You need to be upfront in terms of what am I storing here, where are my logs, all, like things you would with a normal interface, but now you're capturing something much more visceral to people. My voice, my background information, things like that. So it can be amazing, but it's going to be precipitous for a little while. So explore it, play with it, let us know through issues or email me if you have any other thoughts or questions. Thank you for this very, very quick whirlwind tour. I really appreciate it. I'll be available afterwards if you want to talk more, and enjoy the rest of your Dev Summit.